Here we have a Yamaha DY-8 DUSP. It's a mixer. It has a 8-channel input and controls, regular XLR inputs, and a USB /SD capability. Here's the control for the USB digital signal input. It has an equalizer like all mixers do, and the controls. Yamaha is usually a Japanese brand, but in this case I believe it is Chinese. It's not Japanese whatsoever, as we will see when we take a close look from the inside. The customer, when he brought it in for a shop for repair, he told me that there was a heavy smoke came out of it and it stopped working. So here's a look from the inside. This is a look inside of the Yamaha. When I open it up, this is the entire unit. Wow. This type of assembly, it's really good. I like this type of assembly. They are really strong. What I don't like is the way they put the control pods and hook it to the each one by wires to the PC board. Those, it's easy to be serviced, but it is not Yamaha style or any other brand style. They thought it is cheaper this way, so they lower the cost. When I receive this unit from the customer, before I open it, I thought I was dealing with a Japanese unit, but from the glue and the PC board and the type of build, it has a China written all over it. Here's a look at the main power regulator board and the main filter caps with the rectifier bridge and a toroid transformer. And here is the output. This is the entire board, believe it or not, or the entire unit, believe it or not. Here we have the main amplifier that I am going to show you in the other footage. I took it out before and examine it before I decide to make a video out of it, but It's amazing how China build those kind of devices under the name. If it was Japanese, you don't expect to see this kind of arrangement, because Japan always, I'm sure those kind of control parts are really good, and these kind of controls are really good, but a lot of motors. But this is a poor way, and a very poor way to build a control unit for a mixer, especially for a mixer. But regarding all of this, it has blandy wires and a very good connections, but it is not a high grade, and regardless of it is branded Yamaha, it's not Yamaha, it's China all over it. This is the main cooler fan. It's a 12 volt and a little bit of cartridges. Wow. The customer obviously replaced another cartridge. Wow. The customer replaced this fan multiple times, and the complaint was before this unit failed completely that it was blowing up fans repeatedly. The fan wouldn't last even a week. So we are going to investigate that also. Here is the entire regulator circuitry for this unit over here. This unit will supply all the circuitry in this board. On the other hand, this circuitry and those capacitor with this rectifier will supply the A-on-P circuitry. Back on the mixer, the Yamaha. This is a look at the entire amplifier board. Interesting and very good thing about this board is that it has the part values on the PC board. Now those type of capacitors are really low grade. Those capacitors are all junk. This, let me zoom in a little bit. Interesting that this, zoom out a little bit. This resistance is blown up, as we can see from the footage. Every last resistance in this board and in this section is blown out. From the other hand, this board or this side, it's not blown up, but I'm going to take it out anyway and testing each component aside. The PC board, as we can see, there is quite a heavy trace of burning around here. This type of motherboard I don't like, because those type of board are made of fibers, PCB fibers. When they wear out or catch fire or got heated to this point, the PCB became conductive. Overall, it's not a big big deal or a big kind or a best kind of amplifier, but it worked. I believe this type of amplifier will produce a decent 150 watt. Nonetheless, what do you expect from a Chinese product that all other Chinese products are built for a price? Taking a closer look at the other side of the amplifier. Here's the other side. AMP section. These are the pre-drivers, those are the drivers, these are the main drivers. So each channel has two transistors, one push and one pull. The entire capacitors assembly, they needed to be replaced. Those capacitors are blown up, as we can see. Not much to them. They are left. They are using the B or the D 649, and the completion of it is focus. Let's see if they are using the 669. Those are the bias resistance, the VR4 and the VR4 also. Let me see. Okay. The VR4 also. Those are 470 and the other one is 470. Those input transistors are the 5551, that is the number for MPSA 42 and 42, A42. I don't know. The other numbers is the A42. As we can see, these resistors has been melted and arced and even burned the chassis, and those transistors are also bad. So I'm going to disassemble the entire transistors assembly from the PC board and test each one aside and see who is burned out. That's definitely burned out. That's arced in. Even the resistors that is directly connected to this VR is burned out, and that is a what is it, 1.5K. That is really wow. This unit got toasted. This side is toasted. That side of the AMP is toasted. Wow, it's toasted. Let's look at the PCB after we remove those transistors over here. Those, the main drivers, the output drivers, transistors, they're shorted. The pre-drivers are shorted. This transistor is shorted. Those three are not shorted. They are okay, but I'm thinking about replacing all of them because that's what I do. I always start with a new component, fresh component. Now I'm going to test the bias transistor and the control transistor, the bias control transistor, and the two drivers that will they are supposedly driving the output transistors. Here's a look at the resistors after I pull them out of the circuit. As we can see, they are all melted and the PCB is all shattered and burned on. I hope it's not conducting any low or high value resistors. We will see after we test it. The PCB. Here's the motherboard. All the component has been removed from it. After those burning spot, focus, okay, there's burning spot over here and that nasty burn over here. Now we are going to measure across the burn in the 10K analog meter scale. This is 10K and this is the scale, the meter itself. We are going to, I'm not sure how I can do this with one hand, but the poor quality of the board is something. Okay, here we go. Here's the meter. Wow, that was nasty. Now that's on 10K. Let's see if we can lower the scale a little bit and see what happens. That's okay. Wow, that's about, whoa, 50 ohms and lower. Wow, this is why I hate those fiber PC board. When they burn the arc and they become, the PCB become a conductive, like this wire over here. Wow, 50 multiplied with 10, 5 multiplied with 10 equals 50 ohms and even lower. China. Back on the mixer, the Yamaha mixer. What model that was? The Yamaha DY-8D USB. Okay, here is the burn that was all conductive. I removed the burn, and after removing the burn, the short was gone. The carbonized burn was conductive, and I filled that gap with epoxy. It's no longer any conductive. Let's see. Let me pause this a little bit so I can get the meter. Here's the meter, and the same range that we tested the PCB later, that was on 10 multiply with 10. It was giving a 5 or 50 ohm if you push too hard. Here's after we clean up the short. There is no conductivity whatsoever, like it should. There's no conductivity whatsoever, and as we can see, this board has been fixed. Now, after cleaning this board up, all the bias transistor, the first driver for the bias transistor is shorted. This 470 ohm was variable resistor was shorted also. Those entire component is shorted. The capacitor, the ceramic capacitor, this one, the 100 pico, and this one, the 100 pico, and this one is not, they are not shorted. This capacitor is develop a leakage, and the capacity is about 85 microfarad, which is very low. This capacitor is rather interesting because it is PNP. It's non-polarized capacitor, so I don't have and they are hard to find 100 micro on 25 volt non-polarized capacitor. So this capacitor is all it's hard to find. So what I figured out is a simple solution, is assemble two 470, or should I say this guy, 47 microfarad on 25 volts, but it's a BP, non-polarized capacitor. 2 will give, according to the capacitor meter, a 100 micro 100 micro in an accurate reading. So this problem has been fixed. This capacitor will be a budge in this way, and the other one will be budge in a parallel mode next to this capacitor. Those two diodes has been replaced. Those capacitors are not shorted, but all this guy and all the other capacitor will be replaced. This regulator capacitor is dead, and also this regulator IC, which is a 12 volt regulator IC. I am going to replace them now. Also this resistor, the 22 ohm 2 watt resistor, is blown. It's completely blown up. But the interesting thing in this board, they are using a 1 watt 220 ohm, not 2 watt like the board is saying. I'm going to replace it with 2 watt. It's much more stronger and can handle very well pressure, better than the 1 watt resistor. And all of these resistors and diodes are going to be replaced in the new. This is a fresh new component. that I'm going to install in this board. I'm going to install them and back to record this video. Here is the full resistors has been installed, except the 680 ohm and the diode. All those resistors has been checked out okay. This VR resistor is okay. Those resistors are okay, not shorted, discolored maybe, but not shorted and not burned. Now I'm going to install the transistors and the other component, and I will be back. Here's all the other component has been installed except that diode over here. Here's the 2 watt 220 ohm. Here's the driver transistor for the output transistors. I replaced this 5 watt 0.1 ohm resistance because it was blown up from the inside. All the capacitors has been changed. All what left is solder this IC over here and install a regulator for the fan, which is a 12 volt fan. This fan should be 24 volt and it's not available. And all what left to do is solder those output transistors and install them in the heatsink and power it up and see what happens. Here's a look at the chassis after we install all the component. The IC has been replaced. This capacitor has been replaced and this capacitor as well. Here's the other side of the board. This is a little bit of cooling paste. I'm going to clean this up, and this is ready to be installed. Here's the cooler itself. The power transistor has been populated. Those model is not available with 2 screws on the side, but this model uses 1 screw, and I installed this one with a nut from the other side. So this one is ready. I'm going to install it, hooks those two up and assemble them and screw the 2 screws that hold each one in its place, and install it and see what happens. All back together. Here's the complete assembly. And I'm going to clean the the mixer case and install it and see what happens. As the amplifier board has been put in the mixer cabinet, I installed the last component, which is this diode over here, and I installed a 12-volt regulator for the fan, so we can supply this 12-volt fan, the correct voltage to it. And there is an assembly problem that came from the factory I would like to refer to. The screw holder that which this board over here, there is two screws over here and here. You should mount those screws to a plastic, two-side screw plastic, which is as a bracket, so it can mount this bracket to the metal over here, and also mount the this board to the other side. In order to screw those two screws tightly, you must bend this entire board in order to achieve that. I don't approve in this method, so I'm going to use a 3mm thickness washer in order to make it tightly installed. In their method, they are applying too much pressure to the transistor pins, and that is wrong. This PCB must have 4 screws from for each side of the PC board, and secure it tightly so it doesn't wiggle into the breeze like they say. I hook everything and I even connected two speakers. This is a 200 watt speaker, and this is a very loud speaker. As we can see, it's very loud. It's a 25-inch speaker, and we are going to apply power, and let's see what happens. Okay, nothing blew up or burned up until now. I see some light, an indicator light. Let's see the front control. Oh, well, it's working. It's working. There is a USB. Okay, with the main okay, tape. This is an MP3 tape. Is the phone. We are going to feed this with a USB memory card, and we will see will it work or not. We hope for the best. All the controls are down. Okay, I can hear some hissing from the speaker. That's a good indication. Let's put it okay here. Wow. Okay, let's turn up those volumes, control. Nothing yet. Okay, no. Let's see. This is the left. Okay. Wow. Wow. Let's move to another song that doesn't have wow. It works. It works. It works. Let me check the temperature of the component. I'm using my IRF heat thermometer. This one is reading 39 degrees, and this side is reading also 36 degrees. Moving to the bigger speaker transistors, 20 degrees, and this also 20-ish degrees. Let's see, 13 degrees, rather normal. Let's creep up the volume. Your hands down, now you will kick it. Leave them girls alone for their cause, and take your woman back, baby, and just listen to your heart. When she's calling for you, listen to your heart. There's nothing else you can do. I don't know where you're going, and I don't know why, but listen to your heart. You tell her. Nice. Nice. I really like those results, and the heat confirmed that there is no heat factor or any distortion or any excessive heating in the element or any of the input transistor or any of the driver transistor. So I'm really going to declare that this amplifier is fixed. The only thing I'm going to do is, as I said, going to put an 3mm washer in those two sides and tighten those screw in and assemble it. So this is the end of this video. I hope you enjoy it. Thank you for watching. More to come later. Bye.